Hey everyone, welcome back to the Deep Dive. Don't forget to hit that like button, subscribe to our channel, and ring that notification bell so you never miss out on our deep dives. Today, we're going on a journey to the center of the Earth.
Whoa, wow.
Well, not literally, of course,
Okay.
but we are going to delve deep into the world of minerals.
Sounds good.
Now, if you're a UPSC aspirant or just starting to explore geography in senior school, this deep dive is especially for you.
Right.
We're going to be uncovering the secrets of Earth's minerals, composition properties, and India's resources.
That's a key chapter.
Yeah, a key chapter in your syllabus.
I remember that one.
And even if textbooks aren't really your thing right now, stick around. Understanding the minerals is like getting a backstage pass to how our planet works
That's a good way to put it.
and how we interact with it.
Exactly.
To help us navigate this fascinating world, we have our expert guide with us today.
Happy to be here.
So let's get started. When we say mineral, what exactly are we talking about? What sets minerals apart from, say, just a random rock I picked up on a hike?
That's a great starting point. You see, a mineral is much more than just a rock. Think of it as a very specific recipe created by nature. It has to meet 3 key criteria.
All right, I'm listening.
First, it's naturally occurring, meaning it's formed by geological processes, not manufactured in a lab.
Okay.
Second, it has a defined chemical composition. This means it's made up of specific elements in very precise amounts.
Gotcha.
And finally, a mineral has a highly ordered atomic structure where the atoms are arranged in a specific repeating pattern.
Interesting.
This gives each mineral its unique fingerprint, so to speak.
Okay, so it's not just any random rock. It has a specific chemical makeup, and its atoms are arranged in a very particular way.
Yeah.
Can you give us a visual? What does this ordered atomic structure actually look like?
Imagine a set of building blocks, Lego bricks, if you will.
Oh, I like Legos.
Each brick represents an atom of a specific element. Now imagine those bricks locking together in a precise repeating pattern to create a complex and beautiful structure. That's essentially what's happening at the atomic level in a mineral. This arrangement, called a crystal lattice, determines many of the mineral's physical properties, from its shape and hardness to how it breaks and interacts with light.
That's a really helpful analogy. It's fascinating to think about these tiny building blocks, creating the diverse world of minerals we see around us. Now, our source material mentions both organic and inorganic compounds found naturally. We know that coal, petroleum, and natural gas are formed from ancient organisms, so they're organic.
Right.
Where do they fit in? Are they minerals too?
That's a sharp observation. While coal, petroleum, and natural gas are incredibly important natural resources,
Absolutely.
they don't quite fit the definition of a mineral.
Oh.
They lack that specific crystalline structure we talked about.
They don't have that very organized structure.
Exactly. Instead, they're classified as organic resources because they originate from the decomposition of ancient life forms. Minerals, on the other hand, are strictly inorganic, arising from geological processes.
Okay, so minerals are the Earth's inorganic building blocks. But where do they actually come from? How do they form?
Imagine the Earth's interior, a hot molten mass known as magma. As magma slowly cools and crystallizes, different minerals begin to form,
I see.
much like how sugar crystals precipitate out of a cooling sugar syrup.
Like rock candy.
Exactly like that. This process, happening deep within the Earth or sometimes closer to the surface with volcanic activity, is like nature's grand chemistry experiment unfolding over millions of years.
Wow.
Different temperatures, pressures, and the presence of certain elements all influence which minerals will crystallize and in what form.
It's amazing to think about these processes shaping the Earth beneath our feet.
Yeah.
Our source material says that a surprisingly small number of elements make up the vast majority of the Earth's crust. Can you tell us more about that?
It's true. Despite the incredible diversity of minerals we find, the Earth's crust is predominantly composed of just 8 elements. Oxygen and silicon are the real heavy hitters, accounting for about 75% of the crust's mass. The remaining essential ingredients are aluminum, iron, calcium, sodium, potassium, and magnesium.
Wow, so we're basically walking around on a planet made mostly of oxygen.
Yeah, pretty much.
That's mind-blowing. And I've always wondered, are there minerals made of just one element?
Absolutely. Some minerals are essentially pure elements in their native form. Think of gold, for instance.
Okay.
When you hold a gold nugget, you're holding a cluster of pure gold atoms bonded together. The same goes for graphite, which is pure carbon.
Interesting.
These single-element minerals are like the foundational building blocks, showcasing the elegance of nature's chemistry.
So we've established what minerals are and where they come from. Now, the real question is, how can we tell them apart? To the untrained eye, they all kind of look like rocks.
Yeah.
What are the clues we need to become mineral detectives?
That's where things get really interesting. We have a whole arsenal of tools and techniques to identify minerals, but it all starts with careful observation. Each mineral has a unique set of physical properties that act like its fingerprint, allowing us to distinguish it from others.
Right.
These properties are shaped by the mineral's chemical composition and that intricate atomic structure we talked about.
Okay, let's dive into those properties. What should we be looking for when trying to identify a mineral?
One of the most obvious clues is a mineral's external crystal form. This is the shape the mineral naturally grows into, reflecting its internal atomic arrangement.
I see.
For example, pyrite, often called fool's gold, frequently forms perfect cubes.
Neat.
Its cubic crystal structure dictates this shape, making it easily recognizable.
So the shape could be a big giveaway.
Yeah.
What else should we pay attention to?
Another key property is cleavage, which describes how a mineral breaks.
Okay.
Some minerals break along smooth, flat planes, while others fracture in a more irregular way. Mica, for instance, has a layered atomic structure that causes it to break into thin, flat sheets, much like peeling layers off an onion.
That's a great visual. But what about minerals that don't cleave neatly? What can we learn from them?
If a mineral doesn't have clear cleavage planes, it will fracture, meaning it breaks in an irregular way. Obsidian, a type of volcanic glass, is a great example because its atoms are arranged randomly. It fractures with those characteristic sharp, curved surfaces.
So you've got shape breakage.
Yeah.
What other clues can help us unravel the mysteries of the mineral world? This is getting really exciting.
I know, right? Well, how a mineral interacts with light can tell us a lot.
Right.
We call this property luster.
Luster.
Some minerals, like galena, have a metallic luster, meaning they shine like polished metal.
Oh.
Others, like talc, which is used in talcum powder, have a pearly luster, giving them a softer, almost iridescent sheen.
That makes sense.
Oh.
So we're observing how it breaks, how it shines.
Oh.
What about color? Is that a reliable way to identify a mineral?
Color can be tricky.
Okay.
While some minerals have a very distinctive color, like the vibrant green of malachite or the deep blue of lapis lazuli,
Oh, yeah.
others can vary widely due to impurities or trace elements within their structure. Quartz is a great example. It can be clear as glass purple, like amethyst pink, like rose quartz, or even smoky gray.
So color can be a clue, but not always a definitive one. I remember learning about streak in school. How does that help with mineral identification?
Streak is a really useful tool.
Okay.
It refers to the color of a mineral's powder. You can test this by rubbing the mineral against a streak plate, which is a piece of unglazed porcelain. Sometimes the streak color matches the mineral's outward appearance, but often it's quite different.
Really?
Hematite, for example, can appear black or reddish-brown, but it always leaves a distinctive reddish-brown streak.
That's fascinating. It's like a secret code revealing the mineral's true identity.
Yeah.
Are there any other optical properties we should be aware of?
Absolutely. Transparency is another important characteristic, just like we have transparent, translucent, and opaque materials in our everyday lives.
Yeah.
Minerals can also exhibit these properties. A clear quartz crystal is transparent, allowing light to pass through it easily. A piece of frosted glass is translucent, scattering light as it passes through, and a piece of wood is opaque, blocking light completely.
Okay, so we've covered shape, how it breaks, how it shines its color, its streak, and how light passes through it. Anything else?
We also consider a mineral structure, specifically how its crystals are arranged. This can give the mineral a coarse or fine texture.
Okay.
Granite, for example, has a coarse grain texture because it's made up of large, easily visible crystals of different minerals. Basalt, on the other hand, has a fine grain texture because its crystals are much smaller.
This is all so much more complex than I realized. We've talked about a mineral's shape, its internal structure, how it interacts with light. Is there anything else we need to consider?
One of the most important properties is hardness.
Hardness.
Okay, which measures a mineral's resistance to scratching. We use the Mohs hardness scale, a scale from 1 to 10 to compare minerals.
Good.
Talc, the softest mineral, has a hardness of 1 and can be scratched by your fingernail. Diamond, the hardest known natural mineral, has a hardness of 10 and can scratch any other substance.
The Mohs hardness scale. I remember learning about that. It's amazing how much information is packed into these seemingly simple rocks. Okay, we've laid the groundwork understanding what minerals are, how they form, and how to identify them. Now let's meet some of the mineral all-stars, the ones that truly shape our world.
I love that idea. Let's start with feldspar, the most abundant mineral in the Earth's crust.
Okay.
You can find it in everything from ceramics and glass to toothpaste and even some types of food additives.
Wow, talk about a multitasker.
Mhm.
Which mineral celebrity is next on our list?
Let's talk about quartz, a mineral renowned for its hardness and durability.
All right, quartz.
It's the main ingredient in sand and granite, and it's essential for electronics because of its piezoelectric properties.
Piezoelectric properties. That sounds intriguing. Can you explain what that means?
Essentially, quartz can generate an electric charge when pressure is applied to it. This property makes it incredibly useful in a wide range of applications from watches and clocks to microphones and even ultrasound imaging.
That's incredible. So quartz is not only beautiful, but also incredibly versatile.
Yeah.
Who else is gracing our Mineral Hall of Fame?
Next up, we have pyroxene, a common mineral found in meteorites.
Meteorites.
It often has a dark greenish-black color and provides valuable insights into the formation of our solar system.
A mineral with an extraterrestrial connection. Amazing.
Yeah.
What other mineral wonders await us?
Let's talk about amphibole, a family of minerals that includes hornblende. Hornblende can form long, needle-like crystals, and some varieties of amphibole were historically used to make asbestos.
Of course, we now know that asbestos can pose serious health risks if its fibers are inhaled. It's a reminder that even natural materials can have drawbacks. Okay, back to our mineral lineup. Who's next?
Let's delve into the world of mica, a mineral famous for its ability to break into thin, flexible sheets.
Mica.
Mica was a key component in old-school radios and electronics because it's an excellent electrical insulator.
Oh, yeah. I remember seeing those shiny layered sheets in old electronics. It's fascinating how minerals have been woven into the fabric of technology throughout history. Who else is on our list of mineral superstars?
Last but certainly not least, we have olivine, a beautiful olive green mineral often found in volcanic rocks.
Olivine.
Some varieties of olivine are even gemstone quality, known as peridot.
It's amazing how some minerals like quartz and olivine can transition from everyday components of rocks to prized gemstones. Now, shifting gears a bit, our deep dive wouldn't be complete without exploring how minerals are categorized based on their properties and uses.
You're absolutely right. Let's imagine we're building a house.
Okay, house.
What kind of minerals would we need to gather? Well, we'd need something strong and durable for the foundation and structure. Something to create walls and a roof.
This sounds like a job for metals.
Precisely. When we talk about metallic minerals, we can divide them into three main categories.
Okay, three categories.
First, there are the precious metals like gold, silver, and platinum. These are highly valued for their beauty, rarity, and resistance to corrosion.
Everyone loves a bit of sparkle. What are the other categories?
Next, we have ferrous metals with iron as the star player. Iron is the backbone of steel, an alloy that's essential for constructing buildings, bridges, vehicles, and countless other things.
And lastly,
We have the non-ferrous metals, a diverse group that includes copper, aluminum, lead, zinc, and tin. These metals have a wide range of applications, from wiring and plumbing to creating lightweight aircraft components and durable packaging materials.
it's incredible to think that these metals, which we often take for granted in our daily lives, originate as raw materials mined from the earth. What about non-metallic minerals? Are they just the supporting cast in this story?
Not at all. Non-metallic minerals are equally important, playing critical roles in various industries and aspects of our lives. Think about sulfur, which is used to make fertilizers that help crops grow and feed the world. Phosphates are essential for producing detergents, and nitrates are used in explosives.
Oh, wow.
Though thankfully they also have important agricultural uses.
So from the food we eat to the cleanliness of our homes, non-metallic minerals are quietly working behind the scenes. And, of course, we can't forget about cement, which is basically a mixture of non-metallic minerals and is responsible for holding our buildings and infrastructure together.
Exactly. The next time you walk past a construction site, you'll see it with new eyes, recognizing the vital role minerals play in creating our built environment.
Speaking of which, our deep dive today wouldn't be complete without talking about India's own mineral wealth.
A very important topic.
What can you tell us about the treasure trove beneath our feet?
India is a veritable mineral powerhouse, boasting over 85 different minerals. It's a significant player in the global mineral market, contributing to industries around the world. But there's a special category of minerals that are particularly crucial critical minerals.
Our source material mentions critical minerals.
Yes.
What makes them so critical, and why should we care?
Critical minerals are those deemed essential for economic development and national security. They might be scarce, geographically concentrated, or face other supply chain risks, making them strategically important. Think of lithium and cobalt, essential for batteries powering everything from smartphones to electric vehicles. Demand for these metals is skyrocketing as the world transitions towards renewable energy and electric mobility.
The World Bank predicts a 500% increase in demand for those metals by 2050. That's a staggering figure.
It is.
So where does India stand in all of this? Does it have what it takes to thrive in this evolving landscape?
India faces both challenges and opportunities in this arena.
Okay.
On one hand, it relies heavily on imports for many critical minerals, especially rare earth elements, which are crucial components in everything from smartphones and computers to advanced defense technologies.
Uh-huh.
This dependency on foreign sources creates vulnerabilities and potential disruptions to key industries.
So reliance on imports is a major challenge. What about the opportunities? How is India addressing this issue?
India is actively taking steps to secure its mineral future. The Ministry of Mines has identified 30 crucial mineral resources and is implementing policies to promote domestic exploration and mining. Additionally, India has joined the Mineral Security Partnership, a global alliance aimed at ensuring stable and sustainable supply chains for critical minerals.
It sounds like India is taking this issue seriously and working to become a more prominent player in the global critical minerals market. Now, our source material also mentions something called deep-seated minerals. What are those and why are they significant?
Deep-seated minerals are those found at depths greater than 300 meters below the Earth's surface. They often lie hidden beneath layers of rock and sediment, making them challenging to locate and extract.
It's like discovering a whole new frontier of mineral wealth. What kind of treasures are we talking about here?
We're talking about a diverse array of valuable resources, including gold, silver, copper, zinc, lead, nickel, cobalt, platinum group metals, diamonds, and more. These deep-seated deposits hold immense potential, especially as demand for critical minerals continues to rise.
But I imagine accessing these deep-seated deposits comes with its own set of challenges. What are some of the hurdles that need to be overcome?
You're absolutely right. The deeper you go, the more difficult and expensive it becomes to explore and extract minerals. It requires advanced technologies, specialized expertise, and significant investment in research and development.
This sounds like a golden opportunity for India to leverage its scientific and engineering talent. By investing in innovation and developing cutting-edge mining techniques, India could become a global leader in deep-seated mining, securing its resource independence for generations to come. This has been an incredible journey exploring the hidden world of minerals, their properties, their significance, and India's role in this evolving landscape. Before we wrap up, what are some key takeaways our listeners should remember?
We started by understanding what defines mineral, its natural origin, specific chemical composition, and ordered atomic structure. We learned how those factors influence a mineral's physical properties from its crystal shape and how it breaks to how it interacts with light and its resistance to scratching.
We explored how these properties help us identify and categorize minerals, meeting some of the mineral all-stars like feldspar quartz, pyroxene, amphibole mica, and olivine. We discovered how these minerals contribute to everything from our homes and technologies to our understanding of the universe.
And we delved into the importance of metallic and non-metallic minerals, highlighting their roles in industries ranging from construction and manufacturing to agriculture and energy production.
We also took a closer look at India's rich mineral heritage, acknowledging the challenges of import dependency while celebrating the proactive steps being taken to secure critical mineral resources and explore the potential of deep-seated deposits. It's a journey full of possibilities for innovation growth and responsible resource management.
So the next time you hold a smartphone, admire a piece of jewelry, or even walk on a concrete sidewalk, take a moment to appreciate the hidden world of minerals that makes it all possible. These seemingly ordinary substances are the building blocks of our planet and our civilization, shaping our landscapes, powering our technologies, and even inspiring our imaginations.
Beautifully said. And remember, this exploration of Earth's minerals is not just for aspiring geologists or UPSC candidates. It's a journey of discovery for anyone curious about the world around us, the intricate workings of our planet, and the fascinating ways we interact with nature's bounty. Thank you for joining us on this deep dive into the world of minerals. Don't forget to subscribe to the Deep Dive for more fascinating explorations and hit that notification bell so you never miss an episode. Until next time, keep your curiosity alive and your mind open to the wonders that surround us.